Welcome back. We'll now go on to the third clip, which is about thinking of your project as a system. The first question is, where does the system you are investigating sit in a hierarchy of systems and subsystems? Let me give you an example. The systems researcher Stafford Beer, back in the 1980s, was thinking about organisational systems and made explicit the hierarchy in which many systems tend to sit. This example, taken from his book Diagnosing the System for Organisations, starts at the top of the hierarchy and gives the example of total industry, in which sits a section of total industry called heavy industry, and in which sits several heavy industries like chemicals, engineering, shipbuilding, and so forth. If one then goes a bit further down that hierarchy, we can see each of those sub-industries like chemicals or iron steel in themselves sit or have subsystems that then have subsystems and so forth. So the shipbuilding industry, within the shipbuilding industry there are a number of subcomponents of that. So the idea when thinking about your research project is to think about aspects of the system with which your project sits. Here are two examples of different systems, one related to the water system and one related to structures. And you can see by looking at the various items, one can see how from the top level, for example, the global water cycle can go down to very small aspects such as atomic chemistry or nuclear physics. Similarly, in the structures side, we have all structures, and then we can think about the man-made structures as separate from natural structures, and so forth down. In talking about your project, it would be good for you in thinking of the context of your project to not only concentrate on that part of the system that relates directly to your project, but think about what is the next level up and what is the next level down with regard to your project. So if you were doing a project that was something to do with climatology of monsoons, for example, in the context and introduction to your project, you would like to set that in the aspect of the atmospheric system, and also to think about what are the subsystems of monsoons that might be important to your study. Similarly, if you were doing a project on structures, you might be doing research into structural systems of bridges, and so the actual structural systems, you would also want people to be aware of the steel bridges, but also the structural elements of those subsystems. So think about your project and see whether you can think about what the various supra-systems, one above, and subsystems might be within your project. And that will help for you to communicate the context of your project to the reader. If we think about research as a system, we can have this hierarchy, and at the moment you might be working on one element of a project, and that is the proposal element, and this element is part of student team projects. So once again, one can think about the context of the important part that you are playing in the research system, and what are the subsystems that make up that part that you are interested in. The tasks or operations you undertake to complete your project can be considered as a system that exists within a broader environment that shapes the task, and a management subsystem to oversee the operation. So once again, drawing on the work of Stafford Beer, he has simplified this and represented this as the simple diagram where there is some operation that is being undertaken. That operation needs to have a management subsystem to control it and to direct it, and that operation takes place within a broader environment. For your research project, you can also think about the tasks which you must undertake. So, for example, a literature review activity is something that you have to do. The things that manage the literature review activity, for example, might be the time frame that you allow in your overall project, some software for managing references, a system of ethics of scholarships that the university has with regard to its code of conduct of research. That literature review also happens within a broader environment, an environment that might include the library, your supervisor, experts, networks of colleagues, industrial context, and so on. And so when you begin a task, think about what do I need to manage that task successfully, and what are the range of environmental factors that might influence the task. And if you have these two together, you are probably more likely to succeed in executing that task efficiently. Another task might be a research activity. For example, you might be working on refining some part of an engineering code for design. So the activity might be analysis to devise a refinement of an existing code. The management of that system will include, once again, the time frame, maybe a budget, the team member communication system, how do various members of your team correspond with each other with regard to working on this process. In terms of the environment in which this exists, once again, library supervisors, networks and so forth, but also complementary and conflicting codes, knowledge of the materials that go towards those codes, what is the process for getting a revision for a code accepted by the broader engineering community, and your prior knowledge. So these are things that one must think about in order to have a successful revision of a code. So to continue on the systems approach, it's very important that you're able to define your project and communicate that in a very simple way to your audience. Peter Checkland was a systems thinker, and in the late 90s and early 2000s, he was working on ways in which systems work and how one might think about them. And he developed this terminology called PQR. P he used as a letter to signify what is the system that you want to transform. Q was code for how do you want to transform that system, and R, why do you want to transform it? So let's think of this in terms of an example. Here is a route definition of a transport project. I want to transform the design of vehicle-pedestrian intersections. So we're clearly defining what is the system that we are interested in doing research on. Q, by creating a model of flow capacity of intersections. So this is a statement of how we want to transform the system. And R, the reason, because the unexplained variability of intersection capacity suggests that much more efficient designs are possible. So by that very simple statement in one sentence, we can convey to the reader or other interested party, maybe listener in a presentation, very quickly, what is the system you're working on, what bits of it are you trying to change, and why would that be a good idea to change that. Now let's think of some alternative possibilities. Still looking at transport projects. I want to improve health outcomes of poor communities by creating design rules for low-cost stream crossings, because the most intractable item for roads in rural areas are stream crossings, and roads are a proven improver of health. So once again, we have a very simple statement, and it would be clear to someone listening to you presenting or reading that statement as to what it was that you were trying to achieve. Of course, projects might have the same Q aspect but different P&R. So once again, a definition of a transport project. I want to improve the water quality in Victorian rivers by creating a new design rules for low-cost stream crossings, which was the same as the previous transport project, and R, because the farm animals crossing streams are the greatest source of pollution. So the actual research that gets done might be similar for two different projects that have different aims and different reasons for doing them. If we think about a structures project, I want to improve the survival rates of earthquake victims by creating design rules for retrofitting, reinforcing in masonry buildings, because 1.5 billion people live in vulnerable structures. Or I want to improve survival rates of earthquake victims, so the same system that you are trying to intervene in, by examining failure modes of stairways, because the current standard ignores an item that killed many people in the Christchurch earthquake. So once again, we have two different pieces of research that share some aspects of the root definition, but might have different reasons and different activities to achieve that. So having established your root definition, then establish who are the stakeholders of your project. Without a clear idea of the stakeholders, it will be difficult to define your project, and communicating the results will be haphazard. Some system thinkers from New South Wales and Victoria, Richard Bowden, Ray Ison and Roger Packham, developed this idea called two cages, which draws heavily on the work by Checkland, who was involved in the root definition that we just discussed. This acronym two cages is listed here, and first of all the question, what is the transformation, draws directly from the root definition. The second part is the stakeholder of the person who this transformation makes sense to. So in whose worldview does it accord with? Who believes the R part of the root definition? Then the question, who owns the system? Because it is the owner of the system that has the power in order to put the transformation that you create into place. It might be the owner of a building site, a developer. It might be an organisation like Standards Australia that controls the standards, the publishing of standards. Who belongs in the community of the system? So the community might be the broader range of people that are interested in various aspects of the system that you are working on. Who are the actors that make the transformation? So, for example, it might be engineering designers are the actors that will put the transformation into place. The guardians. The guardians are those people that will be the voice of those people or organisms that cannot speak for themselves. So, for example, if there a system of research or the outcomes of the research have environmental impacts, the guardians might be people such as environmental advocates, or if you were thinking about a system of changing of standards, the guardians might be the review committees that eventually accept or review and accept standards. What is the operating environment in which you are operating? So this might be things such as the research institution or the broader regulatory environment in which your research is taking place. And finally, what is the system of human activity required in order to achieve your transformation? So which people need to be involved at which stages in order to go from the system prior to transformation until after transformation. And that will obviously include the work by various researchers. There might be many different disciplines involved in doing that system of human activity. So if we go back to the some of those transport projects, so T in the 2 cages is the route definition of the transport project. The worldview might be something like the project makes sense in the worldview of an organisation like VicRoads, who believe that there will be a need to have intersections for mixed flows of pedestrians and cars. The owner, in this case, might be VicRoads, who own the roads, but also maybe the council that own the footpaths. And so in this system of changing intersections, you might have to deal with 2 owners. The community could be pedestrians, motorists, shopkeepers, emergency services, and so on. The actors are the consulting engineers that are employed by the owners to make the changes to the system. The guardians could be people like the Royal Auto Club or Bicycle Victoria or the Chamber of Commerce. These are people that will advocate on behalf of those people that are not directly involved in the project. The environment in which the project would take place could be, for example, the Road Traffic Act, the ergonomics of pedestrians, and so forth. And the system of activity are the steps that need to be taken to achieve the transformation. So what's next for your project? My suggestion is, for a start, that you have a go at developing the route definition of your project. And then, along with your team and your supervisors, reach a consensus on the project stakeholders and the context using the 2 cages analysis. And then come back after you've done this and listen to clip 4 to double the value of your project. Thank you, and we'll see you in the next clip.